Problem number 1, we have an AND gate with inputs A and B, which means the output here would be A and B. Then there's a second gate, which is an OR gate, input C and also B. So the output here would be B or C. Then these two inputs are brought together to an AND gate, except this AND gate has a bubble on the output, which indicates it'll be a NAND. So the output here would be A and B, and that would normally be ANDed with B or C, but then we have to put a line over this to indicate it's the negative of all of that. So this is what D is equal to. Now that we've seen that the output D is equal to the output of the AND gate, and that is ANDed with the output of the OR gate, and the whole thing is negated. Let's now do a truth table. A, B, C. These are all the possible combinations we can have for the three variables. All 8 combinations. You recognize this binary 0 through 7. Let's first of all form A and B. Well, just looking at the first 2 columns, I have 0, 0, 0, 0, 0, 0. Then in the last 2 rows here, I have 1 and 1. Now, let's form for our next column B or C. Draw a line down through here. B or C, 0, 1, 1, 1, 0, 1, 1, and 1. In the next column, let's take these 2 quantities and AND them together. This would be the same as D naught because we haven't got to D yet. So if we just AND these 2 columns, I get 0, 0, 0, 0, 0, 0, 1, and 1. Then when I take the inverse of this, D would give me 1, 1, 1, 1, 1, 1, 0, and 0. And that would be the truth table, and that's the solution to problem number 1. For problem number 2, we'd like to obtain the sum of products and the product of sums expressions for D. Well, the sum of products is easiest. The table we had on the board a minute ago, there were 6 minterms present. And those 6 minterms, as you may recall, were the very first 6. Only the last 2 were zeros. That means I can write this out in longhand form this way. It's A naught, B naught, C naught. That's the very first row. Then we combine that with A naught, B naught, C. And then we have A naught, B, C naught. Continuing the next line, we would have A naught, B, C. Then we'd have A, B naught, C naught. And finally, A, B naught, C, which corresponds respectively to 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, and 1, 0, 1. And that would be the sum of minterms. Now, we're planning to simplify this later in the next part of the problem, in number 3. But right now we finished. This is the sum of products. If you're writing this in the standard minterm form, it's very often written this way. It would be a summation of minterms number 0, 1, 2, 3, 4, and 5. Now we like to write this as a product of sums. If you recall, when we were writing this out before, we saw that, let's look at a D naught column first. That might be the easiest way to start off. There are only two minterms present there. Those would be A, B, C naught, which is minterm number 6, and then A, B, C, which is minterm number 7. If I were to negate this, I can write that D is equal to the negative of A, B, C naught plus A, B, C, and draw a line over it like this. And if I use De Morgan's theorem, I can now write this as A naught or B naught C and A naught or B naught or C naught. And it appears at this point that we have a product of sums arrangement.